Okay, today we have a fun problem that we're going to take a look at. So what we have here is a 4-kilogram object on a frictionless surface. It's tied to a string to a 1-kilogram object which hangs over the edge of this table, and the string runs over a pulley. And for now, we're going to assume the pulley has no friction, no mass. And what we want to do is we want to find the tension in this string, and we want to figure out the acceleration of each block. Okay, now, because the pulley has no mass or no friction, we know that the tension is going to be the same everywhere in this string. All right, so there's a tension force pulling this 4-kilogram object to the right. That same size force is pulling this 1-kilogram object up. Okay, the string is being stretched, so it's pulling in on both ends. All right, so to figure out the tension in this string, the first thing we want to do is draw some force diagrams. All right, now let's think about this situation here. There's a gravitational force that's going to pull this 1-kilogram object down. If we were to cut the string, this 1-kilogram object would accelerate to the ground at 9.8 meters per second squared. But because it's attached to this other block, it's still going to accelerate toward the ground, but at a much lower rate. All right, so for this 1-kilogram block, we know that the Earth is pulling on it with 9.8 newtons of force. Now, there's a force up of T2. Now, because this block is going to accelerate down, we know that the size of the tension force is smaller than the size of the weight. So for T2, I'm going to take the weight and I'm going to subtract MA. Now, this M is 1. So this is going to become 9.8 minus 1A. Now, for this block, I'm going to draw my force diagram right here. I'm not going to worry about the normal force and the gravitational force. There's no friction to the left, so the only horizontal force acting on this 4-kilogram block is T1. And this is going to equal MA. Now, this mass is 4 kilograms, so T1 equals 4A. So we have an expression for T1, we have an expression for T2. We know that the tension is the same everywhere in that string because the pulley has no mass. So we know that T1 equals T2. So everyone knows that 9.8 divided by 5 is 1.96. All right, so I actually did number 2 first here. So the acceleration is 1.96 meters per second squared. All right, and I'm not putting a direction on there because for this block, it's accelerating down. You could say it's negative 1.96 meters per second squared. This block is accelerating to the right. You could say it's positive 1.96 meters per second squared. Let's just leave it as 1.96 meters per second squared. Okay, now let's do number 1. So to get the tension, I can plug A into either of these equations, and I should get the same answer. So T1 is 4 times 1.96. So what is that? 7.84 newtons. And if I did my math right, 9.8 minus 1.96 should also be 7.84 newtons. Another fun little problem.